All right, here are the video notes for lesson 424. It's titled, What If Both Events Happen? And we're going to be looking closely at these unions, these intersections, and these complements of these subsets. And the best way to do this is, I love this lesson, and it's through using roulette, American roulette. And if you don't know roulette, you can YouTube a video of it. They pretty much spin this big wheel, and you place your chips, your money, on what you think it's going to land on. And you see, does that ball land on your number that you're choosing, okay? So the way that it's played is, and I got to be careful not to take too much time here, but really evaluate what they're saying here. This would be the spinner. You would drop a ball in here and it would be spinning, and that ball would land on one of these numbers. And people place bets on what number they think it's going to land on, or what group of numbers they think it's going to land on. And so what's happening here is somebody like K is betting that it's going to land on 0, 2, or 00. They're betting on three things. This person J is betting that the number is going to land between 1 and 18. This person C here is betting that it's going to land either on 4, 5, or 6. D is betting on all four of these that it could land on. F is betting on the first 12, so that means 1 through 12. H is betting on all the reds, and you can kind of see as it's going. E is these two rows here, 13, 14, 15, 16, 17, 18. And so, again, there's a bunch of different ways to bet on the numbers here. And they list them all through here. And so we're going to investigate the subsets. We're going to investigate the entire sample size, some probabilities here, and then what it means to be a union and an intersection. So the first one here, it's saying, what is the sample size for one spin of a roulette wheel? Well, it's just saying, what are all the possible outcomes for a roulette wheel? And we have 00, 0, and then 1 through 36. And so I can even give this one to you because it's a little confusing. We would have 0, 00, and then 1 through, and I'm just going to put ... 36. Okay? Because it's 0, 00, and then 1 all the way to 36. That's all the possible numbers it could land on. Are all the outcomes equally likely? Does it mean every number has an equal chance to be landed on? And the answer is yes, because we're spinning it in this wheel, and it could land on, they're all the same spaced out, it could land on any of those numbers, equally likely chance that that happens. Okay, now on this one here, I'm just going to give you a couple. They give you one, they say A represents 30, and what I recommend doing is keeping these resource pages open in your tabs the entire time. So they're saying A is the subset, if I can find A. A is a subset of 30 because that's the only number it represents. B is the subset of 22 and 23 because it represents both of those numbers. So it wants us to do C through K now. And so if I find C, C is 4, 5, 6. And so I say in my notes here, C, that is the subset of 4, 5, and 6. Okay, and then I go to D, and I say that's the subset. And I got to go find D on my board. D is 7, 8, 10, and 11. And so we put on there 7, 8, 10, and 11. Okay, and I'm not going to do any more than that. I think you can kind of catch on. So what it means with that word subset is just a smaller set of all the outcomes. All the outcomes, 0, 00, all the way to 36, these are just smaller sets of those. Okay? As you keep moving here, they're talking about this first vocab word, very important vocab word for us, the intersection of two events. Okay? The intersection, and I like to call it the overlapping of two events. And so the question really is, what numbers will allow the bettor to win both bets? Okay? And so we want to say, well, one bet is that it's on 7, 8, 10, and 11. The other bet is 10, 11, 12, 13, 14, 15. Well, we're looking at the intersection, or like I said, the overlapping, and the numbers that overlap are 10 and 11. If the ball landed on 10, if the ball landed on 11, you would win both bets. And so that is 10 and 11 is your intersection. Now it's asking for the probability that the ball actually lands on those two numbers. All right, and that's a different question. So see if you can answer that one. If you can't, always reach out and get some help, okay? Here, now we have this idea of the union. So union and intersection, two different things. Intersection was 10 and 11 because they are in both of them. The union of them, okay, is the calculating the probability of winning either the bet on the event 7, 8, 10, 11, or we would win the bet if we got 10, 11, 12, 13, 14, and 15. So we need to think about the set of outcomes that will allow the winner to win one or the other. Okay? and I can help you out here. So the intersection, or sorry, the union here is really just all the possible numbers without letting numbers be repeated. And so we want to say that it's 7, 8, 9, sorry, not 9, 7, 8, 10, 11, 12, 13, 14, 15. So we want all the numbers. We want all the numbers in our union, and we just don't want them to be repeated. Because any of these numbers, if it's a 7, I win one of them. If it's a 10, I win both of them. Great. If it's a 13, I win one of them. So it's really just all the numbers that let me just win. Doesn't matter if I win both. I just need to win. Okay? So now we're going to calculate the probability of the unions in the first column and the second 12 numbers, so 13 through 24. So we're looking for the union of the first column. So the first column is 1, 4, 7, 10, 13, 16, 19, 22, 25, 28. We're looking for that unioned with the second 12 numbers, so 13 through 24. So you're going to do what you did here. You have two sets of numbers. I would write them out first. I would write out the two sets and then try to union them. Okay, and then look at the probability. Okay, same kind of thing for part C. All right, you have the bettors chip in the event of 13, 14, 15, 16, 17, 18, and the others on reds. What is the probability of the union of these events? Again, these are a little more difficult. If you need help, reach out. Here is an equation called the addition rule that helps you solve for the union and the intersection. And so just make sure that you look at this. We have the union is A plus B minus the intersection. And then we have, I think it's just another way of writing it, is the A or B. And you could do it by subtracting out the intersection there. Okay. Now, here we just have an additional problem, again, using the resource page, same one as before, and then you're just going to see or I differ from the event and I, so you're looking at the difference of the intersection and the union of G and I there, and then at this point, I think you'll be good to go, and you can try to use the addition rule at the end there. Okay. Lastly, we have this idea of the complement, and really the complement is this idea. If you know the probability of this one, you can say the red is 1/3, then what's the probability that its complement hits? So if red is 1/3, the complement would be the rest, and so the complement would be 2/3, and you can use that idea to try to answer the question that is presented here. Okay, again, I said it a few times through this. If you have questions throughout the lesson, please reach out and ask. I can make individual videos based on single slides, multiple questions, whatever it is that you need help on. All right, so always reach out when you have those questions.